Hello again. This is Roger Koch-Barr for the Bioelectricity course. We're going to look at another individual topic, one of several that can be merged together to get the axial currents and then the transmembrane currents. This time let's just look at a local voltage loop. So here's my fiber. I have my red dots, which are just mathematical points, not real points in a real fiber, just points for discussion. And I have identified 4 individual points with letters. So this is point A, B, C, D. You notice the obvious that these letters go around in a loop. If I write the voltage for these points, I can write the voltage between A and B as phi A, the potential at A, minus the potential at B. As we said in a very early segment of the course, the potentials are voltages of all the points. That's the potential field. Every point has a potential. And all those potentials are voltages measured against a single common, normally remote point. So maybe I have a point way over here, and I measure the voltage. First I measure it here, then I measure it there, then I measure it here. But I do all these things without moving my reference point. So I get all these different potentials, phi 1, phi 2, phi 3, phi 4, and then similarly for the ones inside, I measure the potentials at every one without moving the reference. We'll imagine that has been done. If I have done that, then the voltage between A and B, this voltage, I can define, as I did before, phi A minus phi B. So what that means is I take the plus lead of my voltmeter and put it on A, and the minus lead of my voltmeter and put it on B. And that's the voltage that I get. If I do that for every different segment in my loop, I can get VAB, VBC, VCD, VDA, and go all the way around in a circle. And as you know, if you do that with voltages and you go all the way back around to where you came from, the sum is 0. Thereby, I have this equation, 0 is equal to the sum of those voltages. Now you notice something about that process. It was a simple process, a straightforward process. We did it for a set of 4 points that are out here in the middle, and we could do it without reference to whatever is happening over here on the right or over here on the left or anywhere else along the fiber. That is, we can complete that voltage loop without having to be concerned about what's happening elsewhere. This is a little point but a big point, because I find if you ask people who haven't thought about this to start analyzing what happens on cables, they start writing an equation for every point along the fiber on the inside and the outside, and it ends up in a horrendous mess, and that mess is unnecessary. So we'll just take a simple walk with one loop, or a simple walk along this walkway. We defined our loop, and we'll use it as we go on to the next segment. Thank you for watching.